Hey folks, in today's video we're actually going to be looking at the part B of this unit where we're focusing on additive relationships. And you can see again our first I can statement right here that you can write the equation for additive relationships given a table of values. Now before we learn anything with additive, I just wanted to review here that in part A, the first part of the unit, we explored proportional relationships. We're already done with that part of the unit now. But in those table of values, we noticed that we were multiplying each of the x values to get the y ones. So for example, in this first table of values, if I take each of these x values and multiply by 2, that's how I get over here to each of these y values. So in the first part of the unit, we covered that the equation here would be y equals 2x. Again, it's because you just double each of them. And another way to find that, in case you don't always notice the pattern, is to just look at here. These are going up by 2. And over here, these are going up by 1, so we can see our rate of change is a 2 over 1. And that 2 over 1 is the coefficient right here, that's the m. So that's everything we covered in our first unit with proportional. Now we have another example right here where we just do times 5. 3 times 5 is 15, 4 times 5. So that equation was y equals 5x. Go ahead and jot these equations down. And then right here, if they're not already there, jot them down. Now we also talked about in the last unit how proportional graphs always go through the origin, because anytime you multiply a number by a 0, the output is also going to be a 0. So that's a dead giveaway. And we can also see here that if you do like a -1 times 3, -2 times 3, and -3 times 3. So for this one, we get 3x. And again, in case you don't spot it, notice these values are just going up by 3 every time. Here, the change in x's, this is going up by 1, so the rate of change is a 3 over 1, and there is the 3 over the 1. Now, sometimes our table of values were this way, so we've got a times 4, times 4, times 4, times 4. And last but not least, if there was division, if you did 6 divided by 3 or 3 divided by 3, anytime you're dividing by 3, that's the same thing as taking a third. So with the division, we just put a 1/3 x. And these were some examples of some proportional relationships that we explored in our previous part of the unit, part A. Now down here, if you have to add a number to get the x values, or sorry, if you have to add a number to the x values to get the y values, the relationship is called an additive relationship. Okay. Now earlier up here, when we said multiplying or dividing is proportional, adding or subtracting actually works for additive down here, because if you add a negative number, that's the same as subtracting. So if you notice subtraction in the table of values, we're still going to call it additive, okay? So adding or subtracting is this new part of the unit now called additive, okay? Adding or subtracting. So down here, when we look at the table of values, one strategy that I have is to try to find where you have a 0 number right here. Since it's not 0, 0, obviously it's not going to be a proportional. And you guys know that anything plus 0 is still itself. So this right here is kind of a dead giveaway that we might be adding 7. And now we can just kind of check the other points to make sure it works. And it does. 2 plus 7 is 9. 1 plus 7 is 8. And then a -1 plus 7 is this 6. So we're adding 7. So the equation for this one is going to be x plus 7. Notice in the previous part of the unit, we had a coefficient showing multiplication, and now we have a constant over here showing the addition. Like I mentioned, I'm going to highlight right here, if you have a 0 and then this -3, that's going to kind of already let you know we're taking away 3. And now let's make sure it works for every single point. If I do 1 minus 3, yep, 2 minus 3, I'm into negatives, and 3 minus 3 is a 0. So for this one, we're going to get y equals x minus 3. Remember, I can call this additive because it's technically the same as if you were to see x plus a -3. Adding a negative number is the same thing as subtracting. But we're not going to see this. I'm not going to write it like this one down here. It's going to be written like x minus 3. All right, now for the next one. A lot of us don't like to look at the negatives, and I'm the same way, so we'll forget about that. We'll jump right to here. That kind of lets me know I'm going to be adding 2, and if I check for the other ones, it does hold up. I've got 1 plus 2 is 3, and if I did -1 plus 2, And if I'm at -2 plus 2, I'd be at 0. So this one's going to be y equals x plus 2. All right, so far we've got 1, 2, 3 equations for these 3 additive table of values. I'm going to erase now this adding the negative just because I don't want us to take notes on that part. I don't want us to see that equation because we're not ever going to use it. I just wanted you to be reminded of why we can get away with calling it additive. All right, now with this one, when we have our horizontal table of values, if we go from 4 to 8 and 5 to 9 and 6 to 10, notice now we don't have a 0 point, and that's okay. We can still spot that we're going to do plus 4, plus 4, plus 4. So this one is going to be an x plus 4. And again, right here with the negatives, it can be a little bit tricky. But if you start out at -3 and get more negative, we're taking away 1, taking away 1, taking away 1. And just to be on the safe side, if I were to extend my table of values, if I keep the pattern going here, this would be a 0. And if I keep the pattern going here, this would be a -1. So if I extend my table of values, this right here is that 0 point showing me that I'm taking away 1. So again, for this table, it's going to be x minus 1. X minus 1. All right, now let's flip over. That takes care of just the intro of table of values where we're either adding or subtracting and calling them additive. And now let's just take care of some of the vocabulary here, okay? You might remember in the previous unit, I'll put it up here kind of off to the side. I'll put it in purple. In the previous unit, our equations were in the form of y equals mx. That was the proportional stuff where m was our rate of change, the slope. So that's the previous unit. And now our equations are not going to have a coefficient, but they're going to have a constant where we're either adding or subtracting. And this number over here, the +3 or the -2, whatever we're adding or subtracting right here, that thing is called a y-intercept. And it's really important that you guys go ahead and write this down right now. A y-intercept is simply where a line crosses the y-axis. And I'm going to jot that down right now. I'm going to type it right here. Where a line crosses the y-axis. Now I'm going to show you what that looks like on the graph right here in a second, but I just wanted to highlight this just so you can have it, that the y-intercept is where the line crosses the y-axis. And quick little reminder from a long time ago that we have an x-axis right here on our coordinate plane, and we have a y-axis right here. So there's going to be a point where our line that we graph crosses this y-axis, all right? Now the thing that's the same is that we're going to input a number here for x. We're going to have an input value, and then the output value is just right here. And the xy is still going to be an ordered pair. So for example, xy, these are going to be points that we plot over here on the line. And so for example, let's go ahead and plot that very first one. If I go back 1 up 2, if I just simply plot the point, here's my first point. If I plot the next one, it's a 0, 3. It's going to be right here. Then I have the point 1, 4. So I'm going to plot 1, 4 right here. And then we're going to plot the point 2, 5 right here. And you might realize here the relationship, we're not multiplying because we don't have a 0, 0. It's not going to go through the origin. Here it's like a +3, +3, +3. So for this one, our additive equation is y equals x plus 3. And now I'm going to come over here to the graph and point out this thing, this 0, 3. This is the y-intercept. If I connect the dots and make a line right here, that is where my line crosses the y-axis. So this point right here that I've now colored in blue, that thing is called the y-intercept. And it is the constant in the equation right here, the +3. So here is the 0, 3, here's the +3, here's the 0, 3, and here it is right here. If you know what this number is, you always know where it's going to cross this y-axis. Okay, the y-axis is right here. So let's try another one here. If we look at this table of values, the ordered pairs, I have just the ordered pairs that I'm getting ready to plot, and I'll plot them here in red. I'm going to go back 1, down 4. That's my very first point that I'm getting ready to plot. All right, then we've got 0, -3, It's just a table of values. I'm just plotting the points. If I go over 1, down 2, and if I go over 2, down 1, over 2, down 1. So we're using those training wheels. We're basically making a line using a table of values. Remember in the previous unit, I had the analogy of riding a bike and said that for a lot of people, when they start out riding a bike, they learn how to ride a bike with training wheels on. So this is us graphing a line, and the training wheels are really the table of values over here, like we need the points. And eventually I'm going to teach you guys how to graph these lines without needing the table of values and only looking at the equation. And I think you can start to see it now. Like if we look at this equation for this table, it's just minus 3, minus 3, minus 3, minus 3. So this time my equation is x minus 3. And since it was a minus 3 in the equation, you see how the blue point is now down here at the minus 3? So like I said, in the equation, if you know this number, if it's like a plus number or a minus number, you know where it's going to cross. All right, now let's look at a couple of key features of this graph. All right, one thing I want to point out is that these lines are parallel. I'm going to have you guys jot that down over here. The lines that we're graphing in this unit should be parallel lines. You know you're doing things right if you make parallel lines. The first one was x plus 3, so it should cross above the origin, while the one here is x minus 3, and it's going to cross below the origin. Now, something that is still going to matter from our previous unit is the staircase. I want to point out the staircase in both of these lines. That the staircase in all of these is up 1 over 1, up 1 over 1, up 1 over 1. Here the staircase, up 1 over 1, up 1 over 1, up 1 over 1. And here it is in the table of values. These are going up by 1, up by 1, up by 1. This is going up by 1, up by 1, up by 1. So the rate of the change here, this rate of change is still a 1 over 1. My staircase right here is a 1 over 1, and that's what this means. And I'll point out right here in green that technically if I put a 1 over a 1 right here, since 1 divided by 1 is still 1, I don't need to write a 1 in front of the x. So we don't see a number right there, and we don't have to. But technically, the 1 that's right here is the staircase, the rate of change. It also works for this one down here. If I put a 1 right here, by making it a fraction, you've now got 1 over 1. You can see the staircase is right here. And if I look at the table of values, my rate of change, the rate of change still works no matter what type of table you have. It could be a proportional table or additive. Right here, if you see that this is a 1 over 1, and then this is going up by 1, there's your rate of change. The staircase is a 1 over 1. All right. The new thing that we're focusing in on is the constant and the fact that it's the y-intercept. So make sure you've got the y-intercept for both of these, that the first one is 0, 3. The next one is 0, negative 3. And again, by definition, the y-intercept is the point where a line is going to cross the y-axis, and that's what I have right here. And I'm going to erase now the y equals mx because that's again from the proportional unit. I don't want to really focus on proportional too much. All right, so down here, let's just do a quick recap. All right, so for this, we've got 5 table of values. And instead of deciding if it's additive or not additive, we're actually going to decide if it's additive or proportional, like from our previous unit. So right here I have it underlined. Remember, additive is the new thing we're learning, where you're either adding or subtracting. And remember, proportional was from the previous unit, where we were either multiplying or dividing. So let's just look at the table of values and see now if we can distinguish between the two. If it's an additive one, we're going to have an equation with y equals x plus or minus a number. If it's a proportional one, we'd have the y equals mx equation where we're showing the multiplication from our previous unit. All right, now for this first one, first thing I notice is 0, 0. To me, that's a dead giveaway that it's going to be our previous unit, the proportional, because anything times 0 is 0. So I'm going to focus on multiplication. So what times 1 gives me 3? 2 times 3 is 6. 3 times 3 is 9. So it looks like for this one, this is going to be a proportional one. And it looks like I'm just going to put a P for proportional. And our equation here is going to be y equals 3x. And to just verify, these are going up by 3, it looks like. So my rate of change is up by 3. This rate of change over here is up by 1. So my rate of change of 3 over 1, I see it right here in my coefficient. So everything works out. This is proportional. We're good to go. Now for the next one, I don't see a 0, 0, I see a 0, 10. So I'm not going to focus on proportional, I'm going to focus on adding. So 0 plus 10 gives me 10. 1 plus 10 gives me 11. 2 plus 10, 3 plus 10. So it looks like for this one, it's going to be additive. I'm just going to put an A for additive. And for the equation, we have x plus 10. The rate of change, I just want to confirm, this is going up by 1, up by 1, up by 1. These are also going up by 1. So technically, there's my rate of change, the 1 in front of the x, but I don't need it because 1 times x is just x. All right, let's take a look here at the next one. So I do have a 0 point. It's 0, 0. So this, to me, I'm thinking we're back to proportional. Let's see, 4 times 2. If I do times 2, negative 4 times 2 is negative 8. Yep. And if I do times 2, good. So it looks like we're back to proportional for this one. And it's going to be a 2x. We're doing times 2. All right. Now I do want to point something out here with the rate of change because some of y'all might be looking at it. See how these are going up by 8, up by 8, up by 8. So this went up by 8 on this side, but check it out. These are going up by 4, up by 4, up by 4. And if I do the rate of change, what's 8 over 4? If I put it 8 over 4, isn't 8 divided by 4 a 2? So yeah, my rate of change is a 2, and it lines up right there as the 2. So everything's working out perfectly. All right, and now for the next one, okay, so for the first time, we don't have a 0 in the table of values. All right, so this one's going to be a little bit tricky. This one, if we look at it, I could say, all right, I'm either subtracting 1.5 or I'm cutting it in half. Now here I'm subtracting 2 or cutting it in half. It looks like we're cutting it in half every single time. So for this one, if we're cutting it in half, that is proportional. We're dividing by 2. So for this one, we're going to have a 1/2 x. We're taking half. Now that rate of change that's off to the side, it could still help us. This one's a little bit weird though. This one's going up by 0.5, by 0.5, by 0.5. So we're going up by 0.5. And these are going up by 1. And I'm not trying to confuse you, but if you think about it, 0.5 divided by 1, anything divided by 1 is itself. So here the rate of change is a 0.5. And that makes sense because there's the 1/2. There is the rate of change. All right, and now I'm going to, just because it's getting a little messy, I'm just going to erase all the green rate of change things off to the side, just because I don't want it to overcomplicate the notes. Let's just get rid of that real quick. Okay, cool, here we go. Boop. All right, and now we are on the last one. And it looks like for the last one, I don't see a 0 point, so I can't really use my shortcut. So I can either look at just point by point and say, okay, so this could get cut in half, or take away 1. If I were to cut 6 in half, I'm looking for a 3, so I don't think it's a division thing. Looks like it's just minus 1, minus 1, minus 1, minus 1. So 2 minus 1, 6 minus 1, 10 minus 1, 14 minus 1. So yeah, this one right here is going to be additive. And our equation here is just going to be x minus 1. We just take away 1 every single time. So to recap, we had 3 proportional ones here. Multiplying or dividing is proportional in blue. And if you're adding or subtracting, that's the additive relationships here in red. And now what you guys are going to do is you're actually going to come over here now, and on the next page, you're just going to do something similar like what you did in the last packet, but you're just going to come through like what we just did, and you're going to decide if it's additive or proportional. If it's additive, you can just put an A. If it's proportional, you can put a P. However, if it's additive, I want you to write the x plus b equation. And if it's proportional, write the y equals mx equation, kind of like what we did down here at the bottom. Notice how I wrote the equations after I decided if it was additive or proportional. And then there's going to be a Google form for you guys to fill out after that. And that concludes this video. Thank you for watching.